Hello and welcome everyone to this PASS Marathon Analytics. We are excited you could join us today for Shane Underwood's session, Visualization Best Practices for Explainable AI. This PASS Marathon features back-to-back webinars delivered by expert speakers from the PASS community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name is Javier Villegas, DBA Manager at Mediterranean Shipping Company, Microsoft MVP Data Platform, and member of SQL Argentina PASS community. I have a few introductory slides before I hand over the reins to Shane. Next slide, please. If you require technical assistance, please type your request into the question panel located on the right side of your screen and someone will assist you. This question panel is also where you may ask any question throughout the presentation. Feel free to enter your question at any time, and once we get to the Q&A portion of the session, I will read your question aloud to Shane. You are able to zoom in on the presentation content by using the zoom button located at the top of the presentation window. Please note that there will be a short evaluation at the end of the session, which will pop up right after this session ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete this. Next slide, please. Keep learning all year long. Visit PASS.org and check out all the free educational resources available to PASS members. Connect, share, and learn. Next, please. This PASS Marathon session is presented by Shane Underwood. Shane is a Senior Director at DataRobot and founder of Impact Analytics. She has 20 years of experience in hands-on analytics development and has held roles on Microsoft BI product teams. Today, she provides industry analysis to the market intelligence services. Next slide. And without further ado, here is Shane with Visualization Best Practices for Explainable AI. Shane, all yours.
Thank you, Javier. Welcome, everyone. Today we're going to talk about best practice visualization for explainable AI. I'm going to walk through an introduction, show you explainable AI in action so you understand what this means, and then share resources for you. This is one of my favorite areas of research right now in the industry. It's all bleeding edge per se for everyone and all vendors in this space, and quite exciting and an excellent topic for folks that are in the PASS community that may have experience building dashboards or working with data to take their skills to the next level. So before we dig in too far with visualizations, let's just clarify machine learning and artificial intelligence. I get this question often. So machine learning models, when you think about what a model is, and I'll be mentioning this quite frequently in the presentation, they're really designed to answer really short, narrow, defined questions, kind of like yes, no type things. Maybe is it a cat? Is it a dog? Very, very short answers. The models themselves will learn from historical data, and they will make predictions then on new data that's fed into it. And I have a better slide that will show that process. AI, so when you think about AI, it takes the output from machine learning models, but also applies business logic to it to take actions and make decisions on that information. So why is it called machine learning? I have an example here with housing and sale prices of homes, and a model, for instance, for folks that have, remember your statistics classes in school. It's the orange line there is what we would call a model. That's a regression line, and as the square footage of the house increases, so does the price of the home, and each individual home is a dot on the plot here, and that gives you an idea for how the machine actually will learn to find a pattern in data. Now in reality it's much more complex, but on a very simple level, just to understand what a model is, it's this type of concept. I mentioned in the first slide that it's, machines will learn from data. What the machines will do is you'll train, think about almost like training a child or a pet on learning from historical examples and algorithms. You may hear that in the industry. Think about them as blueprints that you'll apply, and you'll find the best one to create a model. And then once a model is developed, then you're going to use predictions and apply it when the new data comes in. And this is where we're going to start today, is really with the decisions and predictions. And why did the machine make that decision? So with automated machine learning, it really applies to many things. I have the easy button here in the world that I'm working in, but there's AutoML and other platforms. There's AutoML that's open source. There's all sorts of options that you can have where you load the data, the machine then automatically analyzes for you. In some cases, it's hundreds of models, and will help you pick and rank the best one to deploy. And typically what I'm seeing is the output from these, and it doesn't really matter what vendor you're working for, or what vendor I should say you're even using, there's this big gap in the industry, and this is where I study and I spend most of my time right now, is helping folks interpret the results and translating gobbledygook into human language that the business can use. Because there's no point in having a fantastic machine learning model that can have a huge ROI if it's just going to live in a PowerPoint slide. And the stats for deployments, I just did an article on Information Week about this. It was something between 50% to 90% of machine learning projects fail to get deployed. So it fails at the point of bringing it to the business. You've got a model, it's much easier to build a model, but what happens is you have folks that can't explain the model, and there's many of the reasons why projects don't get deployed, but the business needs to trust it to really motivate change and to really embrace the positive, things that can happen when you start applying AI to business processes. And machine learning, and you think about the language a data scientist speaks, they'll say, well, the log loss is this, or the ROC is this. The business cannot relate to that, and so it just means nothing, and all of the good work that you've done is useless, and that is something we want to prevent. So is it possible? Well, in some types of models, it's not going to be very straightforward. There'll be very easily explainable models, and then there'll be models that will be almost impossible to explain. But what you can do is understand what influences the results of that model, and if you change inputs, how does it change the output of the model, to kind of get a feeling for how that model behaves. So that might be enough to know your downstream tasks. Why is this important? Well, one of the reasons aside from really being able to deploy models and make them useful for the business is also knowing the limitations and figuring out, well, the model might be incomplete or they might have issues. There was an issue last year with Amazon and recruiting model to recruit employees that, or I should say prospects that were applying when you would put in a job application. They had a machine learning model that would narrow down all the applications that Amazon gets, and a data scientist created it, but they never really opened up that black box to figure out what was happening behind the scenes. And what was happening was that even though they didn't have gender as one of the features going into the model, there were other pieces of gender that were reflected within the data itself. So it was sports, for instance, women's basketball, women's soccer, whatever the situation was there for sports, and the other types of data within that model was capturing what would be, in this case, it was bias and illegal activity. In that case, you're legally disqualifying women from getting a job at Amazon because they're a woman is not quite right. So it's these types of things that can get exposed as well. You can also find things that are just totally missing. So there's a couple of different things that this will really do, but probably one of the biggest thing is just understanding how the model works is super important for the business to embrace it and potentially use it. So some examples of explainable AI. Here's one of images. And if you think about, what is it and why is the machine, when you think about explainable AI, think about a small child saying, why, 100 times in being able to explain that. So in this case, we have some images here, and why do the images match? Is it because the mirrors look the same? Did the machines choose that, or is it because they can actually detect it's the dog? So in this particular case, it's looking at what we call saliency of the image, and you can see in this last picture on the right hand of the screen, it's actually looking at the different pieces here that are matching and not matching, so you can take a look, did it make sense or not? Some other ones, and I'm going to show you these live. I have one with readmissions, another one with readmissions, and this one's on the Power BI community site. We have cause and effect with what if analysis with the readmissions, just another way to show what negatively and positively influences an outcome, the specific features. In this case, this first scenario for a patient readmission is saying, no, it's 70% not likely to be a readmission, and it's because of the diagnosis, the number of inpatient stays, and I can't say this word, I'm not even going to try. But you get the idea. And the reason the negative influence is the insulin, diabetes, metformin. And ironically, I'm taking care of my dad right now, and he's diabetic, and I make sure he has metformin 2 times a day. That's funny, I never realized that. All right, so let's take a look at some of these. And my last one, and I've shown this one before, so I won't spend too much time on this, is just putting some explanations in your dashboards, so not just the predictions themselves, but also the explanations. So let's see these live. And the first one that I'm going to show, and why I like it, is it's a patient readmissions one. This one's been done by Tableau Zenmaster in the community. So we have the potential here from explaining a potential readmission according to all the different patients. So you can kind of get a feeling for the whole distribution of factors in the readmissions. We have the probabilities by different types of criteria. So weight, for instance, you can take a look at the reason why this person might be readmitted. We have the reason strength, how strong are these reasons? Why is that patient likely to readmit, and along with the probabilities. And this is human friendly. So nurses and doctors aren't necessarily machine learning experts to know the probabilities again, or the log loss, or all those types of terms that scientists use, but this makes sense. We can look at number of outpatients, visits, weight, diagnoses, specialty, and diagnosis codes. So these are things that the doctors and nurses can use. The other thing I really like about this example, when you think about making dashboards very actionable and what is someone going to do with this information now that they understand this, is the proactive measures. So at an individual patient level, in addition to what's been predicted, we're providing a proactive guidance as to what to do next with this information. So what next? Why and what next is really key. Another way of showing, and this is the same data set, this one's developed in Power BI and was shared by Nathan Patrick Taylor on the Power BI community site. Here we can change nurses here, and we can look at different factors, and we have just a different summary. Again, going ahead and using some of the tool tips in Power BI, we're putting in the patient's name, the primary reason why there might be a readmission and the strength of that readmission, along with other, human language, what's contributing to that, the primary factor and the secondary factor. Some other things Nathan did, and I do like this, is he's even looked at some of the words that are in the diagnosis subscription, so highlighting with red the more important words. So heart failure in readmissions might be something that would be more likely to readmit, where if you're having neoplasm, that's probably an example of one, or a hemorrhage is less likely to readmit. So there's different creative ways that you can use explanations. Another example, and this one's kind of fun, what I like about this is a before and after. So if you have to explain to the business why use a model and why your model is better than not using a model, this is an example of that scenario. So what we have here is we have just no model at the top and using a model on the bottom. And for each different credit score, so this is, once you have higher credit, you've better chance of paying back your loan. We can get a feeling and we can compare and contrast using a model or not using a model, how our profit and losses might fare in that scenario. And when we look at loans that might be risky, so in this case, if we look at those E-loans, and it looks like there might be a loss on those loans without using a model, and you say, well, we're not going to loan anyone with an E credit score any loans, you can see the difference, 39,000 in a loss versus 329,000 of, or 321,000 of profit by using a model and being more strategic with, oh, I guess we don't have this. Hold on a second, I'm lying to you. 62,000, there we go. Oh, I have to use control click there. So in this case, we can take a look and we can compare and contrast if we choose to use the model and making loans, how that makes a difference. And again, the business will understand the bottom line. They wouldn't necessarily understand the probabilities behind here, or if I put the data science-y language in here. And the last one I'll show on this for this particular section will be one I've shown before. So if you were in my sessions at Past Summit, I showed you and we walked through this example at length. But just an example of taking prediction explanations and going ahead and putting that as well, analyzing the prediction explanations themselves in charts, as well as hovering over, again, putting in the explanations with the reasons why inside of the comments. So there's many different ways that we can leverage different types of predictions and how it makes a difference. And again, putting it into language the business will understand. In this case, I've got, it's even with trends here, yellow is what we want to avoid. If we can see changes in trends, then we know it might be a problem. So with Chryslers, we learned Chryslers were kind of problematic last year, and PT Cruisers particularly, the rental cars. So if we're in the United States, for people that are around the world that don't know what this is, it's a rental car that's very popular to be resold. And so in that case, after a few years of using it in a rental, it's a high probability it wasn't treated as well as if you had personally owned a car. So those are a few examples of explainable AI in action. Let's go ahead and continue on. So how would you approach explaining AI? Well, the first thing I think it's important for the business, and one thing that I'm seeing in some of my work, I was at a conference in London last year, and one of the insurance companies mentioned that they were having a lot of success with automated machine learning, but their executives really didn't understand what it was, and they literally thought AI was a person, and they wanted to meet them. So when you think about the stakeholders with your project, with machine learning and artificial intelligence, there's going to be a learning curve from them to even understand what a model is in general and what this is. So it's really easy if you've been building dashboards or databases. Some of your stakeholders might understand that, but when you think about AI, it's just this nebulous thing that's much more difficult for people to wrap their minds around. So you do want to help them understand that. Once they understand how machine learning works, then you can start to explain how that model works, what type of data was used to make decisions with it. So that's what we would call transparency in AI. What do the results mean? So this is the translation, and this is the part of the section that I really want to focus on, is how you can learn translation skills. It's probably going to be one of the coolest jobs of when you think about this machine-driven era that we're running into, and we're starting to move full steam ahead into new types of jobs and jobs evolving and changing. This concept of translation is really important, and that's a really neat role that I'm seeing. AI translators, AI interpreters. Some companies aren't even calling this, but they're calling it other things, but it's that skill set that's new. And you think about the topic of data literacy. Gartner it's a paper on data literacy. Click has a whole program on data literacy. I'm sure Microsoft has something on it, but it's another area that all of us are learning this new world together. The next thing on how to explain AI is why. Remember I said, think about being a child. Why did the model behave this way? Why did it predict an outcome? And if you think about, I had a peer of mine say, just think about if you were asking someone that's showing you a number in a presentation, it's what context is this number? Is this high? Is this low? Is this usual or unusual? It's all the context that's really key in the why the machine made a decision. And also, what if you change the scenarios? How does that make a difference? And is it something the business can control? The other area we're going to talk about is confidence. So unlike historical reports that are a firm number, models are probabilities, it's likelihoods, it's not an exact. And one of the conversations I had with one of the airlines that I've worked with in machine learning recently had said one of the tips was to provide a range at the beginning of the project, not just give a firm ROI on the model itself, so that the business knew here's the lowest ROI to expect and the highest ROI that might be possible with the known model as is. You'll also need to answer these questions if you're banking, financial services, any sort of regulatory compliance, healthcare. Again, I've already mentioned concepts of bias and correcting mistakes. There's ethical issues on why a machine is making a decision. There have been, especially with image AI, I'll pick on Amazon again. There was a criminal screening visual. You could scan the person and look to see if they had a criminal record, and the machine was more likely, if it was a darker skinned individual, to identify them as someone to pull, to stop and question, etc. And that's, again, you think about that, that's racist, and it's not necessarily intended to be that way, but the data itself was biased that fed that model being used out in the field. So how do you prevent these types of problems, and how do you explain AI? Because it is something that's going to be new probably to the business, not something they really understand. They're going to see different types of charts and different types of numbers and terms. You open up the black box and you translate it into a language they might be able to understand. So let's do that. So one of the tricks to explaining models is going to be using visualizations. Now, some of the visuals are going to be new, but the whole concept with visualizations is that your statistics or number alone not going to provide context in the big picture, and I kind of mentioned that already. But really, it allows people to just get more trust in the model and feel more comfortable. People are visual creatures, and this whole concept of a visualization speaks 1,000 words, or a picture speaks 1,000 words type thing. That's really quite important when it comes to communicating very quickly and effectively with humans. There's cheat sheets for how to understand models. I have one here. I've also included cheat sheets from scikit-learn, Dalix, and Dr. Y. Those are on GitHub, and I have those links at the end of the session in the resources. So there's many ways that we can do this. But the concepts here, do you want to understand and explain the entire model itself? And if you want to do that, you're going to look at the accuracy and the structure. You may want to look at, does the model fit the scenario, that type of thing, and you'll use lift charts, distribution plots. You might be interested in individual insights of the model themselves. In that case, I've shown some examples of using prediction explanations inside of BI applications, and there's a few other visualizations that we can use. So at the beginning of explaining your results of a project, one of the things you'll want to do is describe the data input for the model. So what did the data use? Think garbage in, garbage out type scenario. In helping limit the scope of sharing what you know as limitations in machine learning projects and AI projects. You'll never have all the data you want, probably. It's going to be iterative, and you'll learn where the model makes mistakes and say, well, what if we get this data, and we'll keep iteratively improving it. So in this case of just understanding where the model's has the limitations, if you're aggregating data, is it, what level is it at? And for all my BI and analytics folks, we're so used to understanding aggregations and what's the grain of the decision that should be really natural to you. That shouldn't be really too much new. But in an AI perspective, what might be, what you might need to clarify, is this a prediction at a device level? Is it at maybe a user level? I've got an example here from Google. They have a lovely, and it's online, I have the link here, Pair with Google.com chapter explainability/trust. It's a nice online resource to walk through different scenarios. And in their example, this is for, I guess, running on a device, gives you an idea of good, in the good example, if you're going to be running night moves, be careful, it's after 6, our run route don't include streetlight data. So they've put in their disclaimers of what's included and not included in the data. And so just saying on the bad example, be careful, it's just not a lot of information for the user. And like, oh gosh, do I go outside? What's the problem? You can make your decision if you know to proceed, because if there isn't street lights in the good example. Continuing on the theme of data, what you'll want to look at, because machine learning and AI is really dependent on the quality of data that's in, and making sure that it's balanced and that it really reflects the real world as best as it can. You look at things like statistics, your distributions, outliers in your data, correlations in your data. And the good news with some of the automated machine learning is the problems in the data, things like outliers, will be automatically handled for you. In other cases, it may not, and you'll have to make a decision on how you want to handle that. And I've given other sessions before on introductions to machine learning and how to handle, data. I have a white paper on this, so if you haven't, you're not familiar with what I'm talking about right now with, treating outliers for machine learning, I do have a white paper on it, JenUnderwood.com. There's ways that you can handle data, but for the most part, a lot of the busy work with prepping data and doing feature engineering and automated machine learning has been removed. You'll still look for the quality issues and see if the machine was able to handle it or not. Check for bias, check for just that it really makes sense. And then always keep in mind the legal, ethical, and fairness aspects when you're designing AI solutions. Probably the most powerful visualization, and I believe Power BI also has something similar to this, the key influencers in their solution, is what we might call in data science feature impact. And again, the business might not understand what that means. You might want to put, like I did in the example with the lemon cars, of just saying, this is the explanation for what most influences an outcome. And in this case, it was the wheel type. And for wheel types in the broken car example, if wheels were missing, that was immediately an indicator that the car was not a good car. And in the past, we talked about the concept of, does that make sense? Well, if you think about it, if the car isn't going to run and you can't sell it, well, maybe you can sell the wheels. And that's exactly what happens when people are selling cars that don't work anymore. And you can see there's other ones in here that do affect price and odometer and age. And this information alone can be really, really helpful for the business. One of the reasons why is if you think about having hundreds of variables or maybe thousands of variables, what really makes an impact on an outcome and what doesn't? What might the business be able to control? Where might they be wasting time? By easily showing them, these are the activity, these features, we call it dimensions in business intelligence, it's called features in data science. This is what influences the outcome most. They may or may not be able to control that to really make a difference. The next one I'm going to explain is looking at the relationship between variables to that outcome that you want to predict. And there's two different charts that do this, do a pretty good job of this. And I put my sources in here. One of them is called, it might be called an ICE plot. You might hear the concept of partial dependence plot, but it just gives you, again, an idea on outcome of what the numbers are. So in this case, it's the number of lab procedures on the one on the left that make a difference. And you can see there's a spike there in a certain range of values that really change the outcomes. And sensitivity analysis, it's a similar concept. It's just been displayed a little differently. In this case, it's age and number of pregnancies. Another one, and this is one of my favorite charts that I've learned in data science, has been partial dependence. So why I like this one, and this is using the car example again, of looking at on the axes, the up and down axes, is that's the prediction, what you want to predict. Is this car not going to be functional? Is this a broken car? And the values itself, in this case, it would be the odometer, how many miles has been driven. And you can see cars with low mileage, less than 57,000 miles, those, you're making a pretty good bet that that car is a good buy. But once you get after 57,000, you better take a close look. You might want to have an inspector in that car. You can see that your likelihood of having a bad car is going to be increasing. And again, from a business standpoint, that makes sense. So it helps you understand not just the features themselves that influence the outcome, but the actual values and the value ranges. And I've seen this chart used for medical scenarios. We've seen it used in anti-money laundering, just to find the range of when folks decide to be naughty, they'll always try to change their patterns, and then you can see where the pattern has shifted. Another example, and this one probably when I started using Microsoft's data science, it was, oh my goodness, now I guess literally a decade ago, when there was the SQL Server data mining and those Excel extensions back in the day, we had decision trees, and you could run really quickly, create a model, and you could query it simply with SQL Server data mining extensions. They were quite nice in SQL code. But the decision trees themselves is something that the business can easily wrap their head around. So it's when you look at, in this case, I have a decision tree for whether or not to give credit to someone. If they're over 40 and a home loan or a homeowner already, yes, give credit in that case. If their income is greater than 5,000, give credit, but if it's less than 5,000, refuse credit. And it's a very simple example here, and I've shared the source of that sample, but gives you an idea how easy it is for the business to understand. In a real world project was with check fraud, and I was in there for it was SQL Server disaster recovery at the time. And I saw that the business analyst was having trouble with Excel, and so he grabs me, he says, oh, you're from Microsoft. So he grabs me and says, can you help me with this Excel problem? And I looked at him like, what are you doing? And he explains to me he's doing check fraud, and he's all these crazy things in pivot tables. And there is a better way, just give me a data set. And I kid you not, the next day all I did was I run their data through a model, and I showed them a decision tree, and they instantly knew there's a better way to solve that problem. And they were able to validate that the model made sense. I couldn't, because I don't know anything about check fraud, but the data that they gave me made sense to the business. Some other things that you can do with machine learning is, again, just looking at what influences outcomes. You can even use text fields and free text fields. And quite frankly, what we found, and I've heard this from several insurance companies now, is if you think about free text, and it's one thing to say, yes, I've got a problem with the machine, or I've got an accident, or all the different scenarios where you fill out a form and someone's collecting data on a situation. Think about all the things that you type into that free text field. It's a lot of good predictive information in there, very context sensitive to the individual situation or that scenario. And in this case, we've got just some different ways to visualize predictive analytics using the free text words and the words that make a difference in that. So if you have a WinStar or a Protégé or a Maxima, for folks that know what those mean for cars, those are highly likely to be problematic. If it's, Sebrings, I'm trying to think what we have here, Prius, those are least likely to have be problematic. And then on looking at it a little differently, and another thing about the word cloud, by the way, is always thinking about the audience itself. A 14-year-old child is able to understand a word cloud. Nurses are able to understand a word cloud. You know, we in visualizations may not like them. We may be a little snobby if we've been, you know, practicing best practices. So I was, you know, like, oh gosh, in a best practice visualization, do I show a word cloud? But in this case, there are scenarios where your audience may not understand or look at anything else, but they do understand this quickly, and that's why I've included it in here. So in this word cloud, the words that are red means that it might be a problem car. So we got the Windstar in there and the Maxa and the Protege, and the ones in blue are least likely. So Impalas, Prius, Uplanders, and that again is very easy for anyone to understand. Another one that you'll want to think about, and we've done this already, I've showed you the example with the wheels in Power BI, is just looking at, you'll hear the concept, is this global at the model level? And how does that, you know, affect that particular feature, affect the global model? And then the individual predictions themselves. So for global models, you might do something like a simple bar chart or column chart. And for locals, a really good example is using a waterfall. And again, usually the business can understand how these individual dimensions or features make an impact on the outcome in context of all the other ones. The next one, and this one here is not going to be something the business is going to understand. So you will have to explain lift, the concept of lift, and in what is, you know, random chance. And in the case with the ROC curve, random chance is this gray line that just goes across in this left visual. And you can take a look, the green is the optimal, so you know, kind of the optimal, and the orange is where we're performing at. So you can get an idea of, yeah, this is how much better it is versus no model scenario. And you'll probably take a look at adding metrics for true positives and false positives, and looking at, again, putting money to the metric or time, whatever your KPI is that you're trying to improve, then translating this ROC curve into that world. The other one here I have is box plots. So again, just taking a look at how does this improve versus maybe some of the other models you might be looking at. Again, this particular box plots would not be something you would probably show the business, but you might look at in picking the best one. Some other ways to look at the models themselves are looking at residual plots and residuals over time. So again, models do change. They're kind of living creatures. You train it, and then you feed it new data, and you might have new ideas, and you may put new features in, and it'll keep evolving. So performance will likely fluctuate over time, and you'll have to, it's called drift in a model, deciding when you might need to improve it. But these are some examples of just looking at how much drift there might be. Understanding where models make mistakes. So as you're explaining models to the business and visualizing this, there's the concept of, we call a confusion matrix. And of course, you probably won't use that term with the business, but what they will understand is, what did the machine get right? That was right. What did the machine get wrong? That was wrong. And the reverse, you know, what did it get right that really was wrong, etc. And you can look and split it out. So one of my tricks, even doing machine learning before it was automated, was looking at where, you know, looking at my predicted scenarios and then going ahead and joining it with the real, you know, in a pilot situation, then joining it with the real, what really happened, and analyzing it visually and segmenting where the errors happen, because that will allow you to improve the performance of the model. But it also allows you to know where the model's limits are. Where was it making mistakes? So it really helps narrow that down. I've mentioned this already, the concept of the model changing over time. Some other ways that you can look at that, it's not just the model itself and the performance, but sometimes, and one of the most frequently asked questions that I'll get from newcomers to data science that have, you know, they've mastered some of the basics, and then they get it into the business. They've got their executives trained, you know, understand some of the basic terms, so they've got them data literate. Then they see performance changes, and their boss will ask, well, why? And they'll say, oh, I don't know. So this is where having not just the model drift over time, but the concept of feature drift. And what feature drift is, just as these are the specifics. So if I were to hover over these, the two yellow ones, those might be the age of the vehicle. And the red one might be, oh, I don't know, the location of an auction where the vehicle was sold. So over time, you'll know specifically, well, these are the things that changed, and then you can look deeper into why did that change and why did that affect the outcome. In this next section, one of the things to think about as you talk about probabilities, and I've already mentioned the airline saying, well, it's one thing to give an idea for ROI, but we need to know the high and low. Here's another fun fact. So I flew to Australia recently, and one of the airlines that I was working with had said, well, we need to know specifically errors and put weights on errors and those types of things. So as you're thinking about that yourself, errors can mean a pretty big difference. In my case with the airline, they're predicting fuel use, and they certainly don't want to run out of fuel and get that wrong. There's a traumatic outcome if that's the case. So you'll want to think about, when you're thinking about your errors, what's the cost of an error? If it's just like an email bounces, it's not a big deal. But if it's a plane crashing, that's a pretty big deal. And really putting context into that. So tying this into probability, first tip I'm going to give you is determine if you should show probabilities. Sometimes it's just a lot easier just to give a simple number, and it won't confuse people as much. And here's an example of hurricanes, and this one's near and dear to my heart here in Florida, of being a little too obvious. You have just a regular human thinking about the general mass population that watches television, and they see these scary hurricanes coming from the, whether it's headline news or all these different weather channels. And then you have the scientists saying, well, we didn't really mean it was exactly going to hit you directly in your town. This is the range of what it hits. And what the human might be thinking, why I think this is a fun but very accurate graphic, is this red line here, that's the range. So this human that really doesn't understand the concept, they're not data literate, they don't know what probabilities are. They don't know if you say it's an 80% probability, it's 80% of 100%. I mean, this is the reality of somebody that thinks AI is a person that you might be dealing with. It's just kind of a cute idea to keep that in mind. So understand your audience and what they may or may not know, and how do you educate them and communicate with them most effectively. So on this theme, here's an example of a good visualization for probabilities. We're showing it ranges, we show it changes. Ironically, I lived through this, I guess it was almost 2 years ago already, and hid in the hallway with the puppies, and my husband, who manages the power grid in Florida, was running around like it was a military operation, getting people's lights back on. But essentially, this gave us an idea. So on September 6th, we weren't too worried about it. We were pretty happy in Tampa. And then September 7th comes and it shifts. September 8th comes. By September 9th evening, we were packing the inside of our house into our dishwasher and our cabinets and our washers and dryers, because if you're going to have a hurricane hit inside your house, you want to protect all your valuables. But this gave us time to make that executive decision. Do we stay or go? And when do we pack up the inside of our house? Another example of probability, I'm going to show this one live. I'm sure folks can remember this, or I'm not sure if you've seen this visualization. It's kind of a fun one. We'll go ahead and show this one. So this is an example used. Now in this case here, again, think about the population of who would be looking at politics, and you're bringing it down to the lowest level for someone to understand. And they say when you're writing, you should write for 7th grade level. I think when you're talking about machine learning and explaining AI, again, think about that 7th grader. If you have maybe a 13 or 14-year-old child, you can test with them. Did they understand what you're saying? And then you know you've been successful or not. But this is an example, and I like it visually. So for folks that develop visualizations, it will give you the range, the high and the low. We talked about this, possibility with different ranges, but it also, as you hover over different scenarios, you can see what is the net impact. It's going to be plus however many seats is what this means. So again, this might be something like an ROI, and I've got another really good example of this. Put it into business context that I'm going to show next. Another example, and this is from, so to give them full credit, Berkeley's artificial intelligence research, probably my favorite example. I'd love to see this in Power BI or one of the tools like that. It's really quite powerful. So it will give you your different scenarios and what does that really mean? So what's nice about this, and we talked about the concepts of true positives and false positives, is on this, the light gray is like a true positive, and the dark gray is a false positive. The light blue and dark blue, similar scenario. So as the loan threshold would change, you can see how this affects the outcomes. So on this, and what's really neat, and this is why I'd love to see this in an interactive tool, we can change. And what threshold of a model means is when you decide, in this case, it's a classification model, when you decide what is going to be the cutoff point for something being, one scenario in the classification versus another scenario, that's what the threshold helps you do. We also have how many loans were correct. So this, again, put into business context, this is how many repaid loans for that threshold. This is how many loans were denied. We've got the average credit score, so something that the business can take action, the concept of what next, as well as knowing how does this impact our bottom line. So as you look and you go ahead and move the threshold, you can see where is this. So you'll probably want to maximize profit, but you'll take a look at, in that case, 570 is where they're going to probably optimize and choose that model because that's where you're going to optimize the profit. So some other things that you can do visually, and you think about, you may have different groups or you may be required by law to make sure that you're being fair and ethical about the way you're giving out loans, for instance, is you can break this out into different groups. And you can look at, in this case, instead of using races, we just put blue and orange. And we can look at the same concepts of what does that really mean by these different demographics per se, and adding what we would call fairness in here. So this is a really great example. I have the link in the deck that we'll be sharing so that if you do want to play with this one, you certainly can and get inspired for your own visualizations. You can do that. Let's see, am I missing any right now? I think I got those. The next one I want to talk about a little bit is this concept of a band chart. When you're thinking about visualizations, and honestly, this doesn't have to be always applied to AI. This could even be in general for your business when you think about even looking at historical ranges of, what are the ranges, the highs and the lows, so that you're not just giving the current number, but giving someone that's taking a glance at a dashboard an idea of what the highs and lows historically have been. You might even use things like spark lines to provide that context as well. That's something we've been talking about again for over a decade. Just simple things that you can apply to give your audience a better idea of the big picture. In this case, some of the tricks that I'm seeing used, again, helping somebody understand where does the machine start to make the decision and what's uncertain in this visualization versus what's certain. So in this case, it's looking at bank estimates of past growth, and they're showing the data, but they're also showing different ranges in here with colors. But they're using any kind of forecast or what the machines made decisions on of the ranges. That's in the gray, and that really helps your audience know when is it they're kind of looking at something that might not be a certain thing. Some other tips that we have, time series. So we've worked with time series data, even if you've done historical reporting for a long, long time. And it gets very easy to visualize, if you only have a couple different series per se, we're looking at, say, the 4 different stocks in this example from a white paper that I've linked in here from Washington State. And we have step charts. Those are probably a little less effective for analyzing them. But then you start looking at all these different techniques. Now, what happens if it gets to be too big? Because your vertical space is going to get compromised. So one of the more recent techniques for handling time series and predictions with many lines. So this is an example from if I have any database administrators on here, this is a fun paper for you to read. But they're looking at memory on servers over time, and they're using it's a concept called dense line charts to really show some of the predictions there of when the server might go down. And they're using color coding, kind of heat mapping overlaid with these dense lines. And it's just a different way to look at this. And they also have it with annotations. So again, providing context. So on A new version was deployed, usage becomes more consistent. And then the B, server crashes. So you can analyze this and explain this to the business. Why did that server crash? And you can explain and look at the pattern. Another time series practice that we're seeing evolve that might be helpful for folks that have lots of time series, and we have that data set. It's a one on the free, I'm trying to think, free data sets that are floating around and definitely floating around the Microsoft community, is the concept of all these different flights and flight delays. If you're looking at that just as a line chart, it's really tough to see the patterns. But if you change this and we flip it around to what we would call a spiral graph, looking at over time, you can quickly start to see the patterns of when flights are grounded and when they're delayed. And in the example here, it's from O'Hare. So the reds are different times and patterns of when delays. So you'd probably want to schedule, if you're thinking about translating this to the business, you want to get those early flights in the mornings. After about 11:30 is when you're going to start running into some delays. And again, the early evening ones. And for folks that fly a lot, like I do, yeah, you try to usually avoid those late afternoon and those late night flights. Otherwise, you get stuck for a day. And the last one I'm gonna walk through, and then we'll start taking some questions, is just the concept of probabilities with workflows. So if you think about, and this is a Sankey chart, and I believe they have these in the custom visuals in Power BI now. This whole concept of what different phase and what different work steps might be. And if you think about AI and explainable machine learning, usually machine learning is applied to a business process. So there's different steps and there's different pieces. So here for this orange one, we can see that it doesn't really affect furniture or office supplies. It's really only technology. And then we take a look at technology in the West, where there's a delivery truck and it's high. So we can really, really look at narrowing down, what is it I can take action on, and how do I know, and how does this affect the business process? And I can do something with this information. So just to repeat what we've learned today, we've talked about what is a model and how machine learning works and how important it is to describe that to the business and not assume that they have any clue what AI or machine learning means. They're buzzwords, they're super overhyped. It's just super confusing for a lot of just regular people out there that are not data professionals to know what that is. We've talked about how the model works and describing what influences outcomes, not just the dimensions or features per se, but also the value ranges and how powerful that information was. How the data used in your model may be limited, or what is the scope of data and what are the known issues that you know about your data. So being transparent, describing what the results mean. So taking things like true positives and false positives and equating that into an ROI in lending or likelihood of readmissions for patients and why. Or in the last case with banking, translating all the way to the thresholds of loans to be approved and not approved, and how that impacts the bottom line of profit and the loans that would be issued, the amount of loans that would be issued by different classes of individuals or demographics. And then why did that model predict an outcome? So we showed lots of different reasons for why and what if, and different examples cooked into dashboards. And again, one of the tips that I would give you, and anytime you're selling AI, you're usually selling change. And change is tough. It's a lot easier for people to be willing and open to think about change and having a machine help them with decisions if it's brought into the world they already know. So if you're bringing it into an application that they're already using, or you're showing it in Power BI, in dashboards they'd be familiar with, comfortable, they're already using it. Maybe it's even a mock-up in PowerPoint, again, in something they already know, will be a lot easier than just giving them numbers and trying to have them visualize how to use this. You'd be amazed at executives that I've worked with around the world that will not be able to recognize just the regular data science charts. We need to bring it into dashboards, and instantly they get it. And then, of course, we talked about, regulatory compliance and uncovering potential issues in your models, making sure that you can be confident with your models. And if you're talking about model confidence and probabilities, again, thinking about that audience and what is their data literacy level, and that 7th grade, think about a 7th grader, does it pass the 7th grade test, so that you can get trust in that model. So some of my favorite resources on this topic for you to learn more, I've got a link in here to an ebook on understanding machine learning models. My favorite one so far is Interpretable Machine Learning. It's on GitHub. I've also bought the book because you can buy it too, I believe, but it's freely available on GitHub by Christoph Molnar. Dr. Y AI, which is another site that will allow you to walk through different techniques for visualizing individual predictions as well as batch predictions, and some other examples in R and Python, so that if you're using open source technologies, you can get the same types of things. There's many different cheat sheets per se for interpretability.
All right. Thank you, Shen. Excellent presentation and excellent timing. Okay, there is one question asking if the audience can get the presentation, the slides.
Yes.
Okay, I mentioned that the recording will be available soon, and everybody is going to receive an email from PAS when it's available. So that's going to happen. I have no more questions for now. Is somebody else has additional questions, please proceed.
Okay.
All right, so please stay tuned for our next session, Power BI from Zero to Hero, with Hassan Nias. Next slide. Thank you for attending, and we see you all keep enjoying this PAS marathon. Thank you all, and thank you, Shen.
Thank you. Thanks for having me.
Bye, everyone.